Hi, my name's Lois Gray from North Highland College. So today I'm going to show you how to test or simulate your half adder using the ISP Lever IDE and VHDL test bench. So we're following on the notes from the section on that, sections 11 and 12 of Electronics 3 in the BEng program, Electrical and Electronics BEng Honours. And we've already created our component, register transfer logic half adder component, using the IDE. So that was task 1, a previous video. And now we're going to go on to task 2, which is to simulate the half adder using the ISE IDE. Okay, so what we're going to do is create a new test bench for this component, which we had already simplified, synthesized and compiled. So if we click on the device and right click, what we want to do is create a new VHDL test bench. So we'll click new and we'll select VHDL test bench. And we're going to associate the test bench with the top level component. Now for more complex designs you can create individual test benches for each subsystem or subcomponent within your design. But in our case we only have the one component, the half adder, so we want our test bench to simulate the actual device input and outputs, not just sort of buried nodes within the device or subsystem inputs and outputs. So just click OK on that. We want to give the test bench a name, so I'm just going to check the name that I called it in the notes. I called it half adder test, so we'll stick with that. You can call it anything you want, of course. Don't use spaces or odd characters though. Okay, something sensible is usually a good idea so you can find it again. And I'm just going to copy and paste the code from the notes. It's the easiest way. You can write it from scratch if you wish. You will need to do that later on when we're doing some more complicated designs, and I haven't given you all the code like I have done here. So we'll just copy and paste that. It's just the normal text commands for copying and pasting. Control C, Control V, right click, copy and paste. I'll talk you through what the file's actually doing. So at the top here we have our libraries defined, and then some other libraries that we're also going to use for this particular test bench. As it's a VHDL file we have to have an entity defined, but of course a test bench isn't a real component, so our entity description is just blank or empty. So we've just got an entity is and then an end entity. And then we're going to define the architecture, which is basically going to map our test bench signals to our component that we're testing. So here is the component we're testing, the half adder. So this is exactly the same as the half adder entity declaration. And then here we're going to map some signals, which are the things we'll actually see in our waveform viewer. These are the test bench signals. So we've got signal A, B, sum and carry. Because it's a nice simple design, we're just going to give those the same names as the ports in the half adder. If you had a more complex design, you probably would find some of these would map to things that weren't the same names. And then we're also going to initialize the two inputs at 0, so that when we first start our simulation, these two inputs start at 0. Okay, so that's pretty much our architecture defined. Then we need to tell the simulator what components are actually being simulated. So starting here, this defines what signals are being simulated, and this also maps the component signals to the signals within, the component ports to the signals within the test bench. So we've got component A port mapped to A signal and so on. And then down here we've got the actual simulation that we're actually going to be doing. So what we're going to be doing to our inputs, and then we'll be able to see what happens to our outputs to check that functionally they are correct. We're not doing a timing simulation at this stage. You remember that functional simulation tells us whether or not the logic is working. Timing simulation tells us whether or not the times are set up correctly, so we're not exceeding setup or hold times or things that, oh, we've got glitches or hazards. So I'm not going to do that today. We're just going to do simple functional simulation to make sure that sum does actually equal A or B, sorry, A and B, and carry, no, that was A or B, sorry, and carry is A XOR B. Right. Okay, so I think that's straightforward. We're going to do some weight statements. Set A high, then set A low, then set B high, set B low, and then we can look at the outputs while that's running. So I'm just going to save that. You'll notice it's still got a VHDL extension here, because it's a VHDL file, even though it's a test bench. Right, close that, and then if we come into our project navigator, we can see that now attached to the device we have our test bench here. So if we left click on that, and we're going to do functional simulation, and we're going to use this ALDEX simulator. You can actually change that in the options menu. Select RTL synthesis or simulator. If you have the model sim 1, you could select it at this time. We don't have that anyway, so we're not going to bother. And just double click on that to run it, and it will bring up the simulator. So we're looking for no errors in this window. Warnings are not a problem. Errors come up in red. Errors indicate a problem either with our test bench VHDL or our component VHDL. So this particular simulator is actually very powerful. It can do design and compilation as well. We're not going to use it for that. We're just going to use it for simple simulation. I'm going to overwrite that because I already had one of these. If you haven't done this before, you won't have. Right. Okay, so some quick tell you what the main features on here are. We're not going to use all of them because a lot of them are to do with compilation as well. In here we've got a sort of hierarchy menu where you can see the build-up of your test bench, which consists of your component and the stimulus, which is your A and B high, low, weight 100 nanoseconds part. We've also got the libraries that are being used. So this is basically everything the test bench needs as lower level files to perform its function. Up here we have a design browser which tells us how the design's actually been built up. So the design is in our work directory, and it consists of a RTL half adder and a half adder test bench. You meant to make sure that that is selected as test bench TB. In here we've got our waveform signals. So these are the things we can see in the viewer. If they're not in the viewer, you can click and drag them and they'll get added. You can right click to remove them. That just removes them from the viewer, it doesn't remove them from the design. We've got a cursor. We can move around in the waveform viewer to actually see timings at specific points. You'll see the values here are recorded where the cursor is, so the first one's all zeros, and then we've got 1001. So that tells you what your signals are doing at that specific time. We can measure the time between signals using this measurement mode. So if we select that, then select our first point here. Oh, right, why is that not letting me do that? Oh, I think you have to click and drag. So that's your first point there. Say we wanted to measure the time, well, check that our 100 nanoseconds between edges going high and low is correct. So you can quite clearly see that that is what's happening. We can also run the simulation again using these buttons. I'm not going to do that. We can set a bookmark using this flag. So say we wanted to, oh, I need to come out of that first. Say we wanted to set a bookmark here. Oh, I think we're still in the measurement mode. How do I come out of that now? Oh. Right, so if we want to set a bookmark, we can set a bookmark here. Oh, still in this measurement mode. How do I get out of that? Back to selection tool. There we go. Yeah, so say we want a bookmark here. I'll just move the cursor along, set the bookmark, and then if we are somewhere else, we can then go to that bookmark. We can go back to a previous bookmark. We haven't got more than one set, so we're not ever going to be able to do that. You can run the simulation for a longer time, and then you might have some signals that come off the edge of the screen here that you might want to see later. Bookmarks are really useful for that. We can obviously zoom in and zoom out. That's quite straightforward. So I think that's pretty much it in terms of what you need to do at the moment. All that remains is to check that our device is doing what it's supposed to be doing. So if we scroll right back to the beginning here, we can see that we initialized A and B as 0. Nothing's going to happen until we start changing A and B. So the first thing we've changed is A, and at that point our sum has gone high, and then we've changed B and sum has gone high. So sum is the exclusive OR of A and B. I think I may have said that wrong earlier, but you should know that from the file anyway. And then carry is the AND of A and B together. So carry will only go high when both A and B inputs are high. So we can see quite clearly that the device is working as expected. And we can scroll along and check further if we wish. Okay, we don't have a lot of data. We could run it for a bit longer, I suppose, to get a bit more data. I'll just do that maybe. Run it for a wee while and then stop. And in a minute we should get some more data. So now we have a good bit more data to have a look at, and we can check that it's working consistently all the way through. So this is where a bookmark might come in useful, you know, if you wanted to check the signal maybe later on in time, but still be zoomed in enough to see what was going on. Okay, that's really about all, I suppose. Yeah, if it doesn't work, then there's all sorts of problems, and you're probably best contacting me to try and figure out why it's not working. Quite often it's because the structure has not been correctly built up, or you've given your file the wrong name, or there's something wrong with your VHDL. But usually the compiler will catch VHDL errors before you get to the stage of simulation. So simulation issues are more to do with file allocations, so not so easy to resolve. Okay, thanks for listening. Bye for now.